LEO and GEO satellites, they have limitations. LEOs have a field of view which is very small, about 6% of the world. The GEOs are always in the same position relative to a distress beacon and are susceptible to blockages in volatile terrain areas like mountains. GEOs also, unless the position is encoded in the distress beacon alert, we can't tell where the beacon originated. MEO, on the other hand, takes advantage of both the LEO principles and the GEO principles. The field of coverage of a MEO satellite is 33% of the world. With the number of MEOs and the field of views, they overcome the limitations of both GEO and LEO for detecting distress beacons, and if you have 3 or more satellites detect the same burst, you're able to instantly pinpoint a location very accurately anywhere on the face of the Earth.
In a situation where time is a critical factor and sometimes means the difference between life and death, being faster is very important, and this is one of the key elements that MEOSAR will bring to the COSPAS-ARSAT system.
MEOSAR is a really truly a game changer for search and rescue responders. You have a LEOSAR that has to get at least 2 passes. And that could take, depending on where you are in the world, that could take anywhere from 30 minutes to 90 minutes. Whereas with MEOSAR, 1 beacon burst, based on the time of arrival, frequency of arrival calculations, could provide you an independent location pretty much immediately. The wait time varies, but it's a very short period of time.
Another big difference between MEOSAR and LEO and GEO will be the size of the constellation. Right now, with the current generation, we have about 8 geostationary satellites that are in orbit. There's 5 low Earth orbiting LEOSAR satellites in orbit. When we get to GNSS, the Global Navigation Satellite System, we're talking about up to 3 constellations that might be carrying our search and rescue capability. So with GPS, that would be 24 satellites, Galileo, another 24 satellites, with GLONASS, maybe an additional 24 satellites. So we're talking at some point in the future, maybe in late 2020s, we could have up to 72 satellites in orbit, extremely robust space-saving capability.
All of these payloads are built to be what we call interoperable. So the signal can be picked up by any of the 3 different constellations, and it doesn't matter. It is transparent as to which spacecraft is picking up the signal at any given time.
It's one of the differences as well that we have on the MEOSAR system is that the MEOSAR, all signals are being relayed directly to the ground, while on the LEOSAR system you have partial processing on board of the signals and retransmitted directly to the ground. Here in the frame of MEOSAR, it's a fully what we call bandpipe transponder, so it's completely transparent. The signal is just relayed and shifted in frequency, so it goes in UHF and goes down in the L band.